What types of inequalities do we have in this lesson? There's 3 listed here. There's simple, right, which is just a basic one inequality problem. Then we have compound, which has 2 inequalities. And then we have absolute value, which we didn't get to yesterday, but we are going to be getting to today. There are basically 4 different scenarios that you can come up with on an absolute value. You either have an absolute value being less than a positive number, greater than a positive number, less than a negative number, or greater than a negative number, which should be down at the bottom. Okay? So if you conceptually think those through, what does this one mean? Absolute value is less than 3 would mean that your distance from 0 is less than 3. Everybody agree? Remember that absolute value is your distance from 0? Okay, so when you say the absolute value is less than 3, that means we're talking about numbers that have a distance less than 3 from 0. So what numbers on the number line are less than 3 units from 0? All right, all the ones in here, right? All of the numbers between -3 and +3 are less than 3 units away from 0. So yesterday we talked about how this is really just an and problem, right? Okay, whenever you have something in between, that's really just an and. All right, so this one says the absolute value, that means distance from 0 is greater than or equal to 3. So that would look like this. Numbers that are more than 3 units away from 0 would be all of these and all of these. So when you see an absolute value and it's greater than a positive number, it's really just an or problem. Okay? When you see an absolute value and it's less than a number, less than a positive number, it's really just an and problem. Okay? And then the 2 other case scenarios that if you catch, just always remember when you get an absolute value and a negative number, you need to be thinking, am I dealing with a special case here? So like on this one, you have an absolute value less than a negative number. Well, what does absolute value mean? Distance from 0. Can a distance ever be less than a negative number?
No.
Distances are always positive, right? So it's impossible for a distance to be smaller than a negative number, so that's automatically no solution. Don't mess with working the problem out. Does that make sense? Okay? No solution. This symbol right here is called the empty set symbol, and it means no solution. Okay? That's what you could use for interval notation when you're doing a no solution problem. Okay, this one, absolute value is greater than -3. Well, absolute values always come out positive. Do you guys know of any positive numbers in the world that aren't bigger than negative numbers? Aren't all positive numbers bigger than negative numbers? So, I mean, everybody in this room should be able to pick a number for x, a different number, and that should come out true. Because all numbers are bigger, all positive numbers are bigger than -3, right? So that means every number in the world works. Can you think of any number that wouldn't work here for x? They should all work, right? What about -6? What's the absolute value of -6? Okay, is that bigger than -3? Yep, they all work. So in this case, we have a script R or negative infinity to positive infinity. Does that make sense? All right, so remember you can always look back at this thing as a guide to help you when you first see your problem. All right, let's go to... Let's see, what example are we ready for? Are we ready for 5?
Yes, that was
Okay. All right, so here's an example. Oh, okay, so we are ready for the absolute value one's great. So before we do that real quick, I want you to grab this sheet. Okay, I handed this one out yesterday. So grab that sheet. And this is a matching sheet, and we want to match these with the sentences that are down at the bottom to see if we truly understand what absolute value with inequalities mean. Okay? So your first choice is what? And what is, basically, describe to me what the first number 1 says.
the absolute value of 3x plus 5 is equal to 0, or 10.
Okay, the absolute value of 3x plus 5 is equal to 10. So that tells me that this quantity right here is exactly 10 units away from 0. So see if you can look down here and match that with one of these choices.
E.
Okay, letter E says the quantity 3x plus 5 is exactly 10 units from 0. So number 1 should be E. Okay? Now there are 2 sentences down there that represent 2 and 2 that represent 3. And so see if you can figure those out. I'll give you just a few minutes and then we'll go over those. What you got on these? So for number 2, it's an absolute value that's less than 10. So which of the bottom describe that? F is the quantity 3x plus 5 is less than 10 units from 0. That is correct. So F would be one of those. And then we also have which one? C?
C.
Okay. So F and C. Why C? 3x plus 5 is in between 10 and negative 10. Well, if that quantity is less than 10 units from 0, then all of the numbers between 10 and negative 10 are less than 10 units from 0, right? So any number in between then would meet that criteria. Okay? All right, number 3. I'm looking for this quantity being more than 10 units away from 0 or exactly 10 units. 10 or more. So which ones signify that?
A and T.
A, the quantity is exactly 10 or more units from 0. And which one?
T.
A and D. 3x plus 5 is greater than or equal to 10, or 3x plus 5 is less than or equal to negative 10, right? So it's just basically saying an or problem for that. Remember, an absolute value greater than a positive number is really just an or problem. So we had A and D. Okay, so how about this one? The absolute value is less than a negative number. Is that possible? No, a positive number can never be less than a negative number. So which one signifies that?
G.
G. Okay. And then what are we left with for 5? B. Okay, because X could be any number because your absolute value is going to come out positive no matter what negative number you put in there. Okay, is everybody okay with that? All right, so let's go on to example 5. And it is a 2-step problem, and when you look back at that reference sheet, you go, oh, this is an absolute value inequality. Now, anytime you do an absolute value inequality, you're going to want the absolute value by itself. So my first step to solving this problem should be to do what? Divide by a 3. So if I divide both sides by 3, divide by 3, divide by 3, I'm going to get the absolute value of P plus 1 is less than or equal to 5. Right? Okay, well, what does that mean? Talking about an and problem here or an or problem? This is an and problem. How do you know that? Because the absolute value, you have an absolute value and what? Less than a positive number. And this is where you're going to get out that sheet that has the 3 columns on it. You're going to get out that and go, okay, I'm in the absolute value column, and I have an absolute value, and it's less than a positive number. Everybody know what I'm talking about? Everybody know what sheet I'm talking about? Last column, you're looking for an absolute value less than a positive number. And you kind of have to memorize those a little bit, but anytime you have that, that's an and. So this means that this quantity right here, this P plus 1, and this isn't the final answer graph, so I'm not putting it down here, but P plus 1 comes in between what 2 numbers? 5 and negative 5. P plus 1 is somewhere in here, right? This P plus 1, this quantity, has to fall in between 5 and negative 5. So all I know is that P plus 1 falls in between these 2. So this is where P plus 1 is. P plus 1 is somewhere in between these 2. Well, I'm not asking you to figure out where P plus 1 is. I want to know where P is. So but I can write a statement from this. I can say, well, if P plus 1 falls in between these 2 numbers, I can write that like this. P plus 1 is less than or equal to 5, and at the same time greater than or equal to negative 5. Okay, P plus 1 comes in between negative 5 and positive 5. This is a shortcut way to write an and statement. Okay, it means that p plus 1 is less than this, but at the same time greater than or equal to this. Okay, it's basically saying you have two arrows that overlap from here to here. Okay, well, how do I solve one of these? Subtract a 1 from all three parts. So if I subtract a 1 from all three parts, what will I get? -6 less than or equal to. P is less than or equal to what, 4? All right, so P is any number between what? -6 and 4. Okay, so I need to write that in as a graph and also in interval notation. Well, interval notation, anything from -6 to 4, include them, is going to look like this. From -6 to 4, include them both. On my graph, that's going to look like this. -6, 4, and when you go to do the graph on the computer, what they'll do, you'll select bracket, bracket, and then you'll pull the brackets to these points like that. Okay, is everybody okay with example 5? Okay, we're ready for example 6. If I can get it to scroll. Okay, so example 6, it's another two-step problem, and it is a absolute value inequality, so we are once again in column 3 on your reference sheet. Does that make sense? Okay, column 3. So 2 steps, and you have to, first of all, what am I going to do? I got to get the absolute value by itself, so I need to divide by what? Divide both sides by 4. So let's divide both sides by a 4. And when I do that, I get the absolute value of P plus 4 is greater than or equal to 1. Okay, well, look in your sheet in that right column. What type of problem am I dealing with here? It's an OR. How do you know it's an OR? Because if you look at your sheet, absolute values that are greater than a positive number means an OR problem. So I want to write this as an OR problem because this P plus 4 is any number that's more than 1 unit away from 0. So I want you to think about what numbers are more than 1 unit away from 0. Here's 1. Here's -1. So I'm talking about these numbers and these numbers. So that's where P plus 4 is. P plus 4 is either in this region or it's in this region. So I'm going to write an OR statement that reflects these two arrows. This arrow is P plus 4 is less than or equal to -1. Right? If I had to write this algebraically, it would be P plus 4 is less than or equal to -1. So P plus 4 is less than or equal to -1. Okay, well, what if I write this arrow as an algebraic statement? It would say what? Right, P plus 4 is greater than or equal to 1. Now notice that this one looks just like this one without the absolute values, and this one looks just like it except for this sign has been flipped and this sign has been changed. Okay, this is exactly the same as this. We just flipped this, changed that sign. This one stays the same, just take the absolute value off. But conceptually, what it means is I'm writing an OR statement off of this picture. And this picture I got from here, because I know I have to be more than 1 unit away from 0. These are the numbers that are more than 1 unit. These are the numbers that are more than 1 unit. So I write an algebraic statement for this, and that gives me this. So now I just need to work both of those out. So if I work both of those out, what will I have to do that? Subtract 4. So subtract 4, and I get -5. Subtract 4, and I get what? -3. All right, so I got P is less than or equal to -5, or P is greater than or equal to -3. So I need to mark my -5 and -3. Looks like I have closed circles on both. I'm supposed to be less than or equal to -5, greater than or equal to negative 3. Okay, so there's what it looks like in graphical notation. Now I've got to write the answer in interval notation. So what's this going to look like in interval notation? Okay, is everybody okay with that? We started at negative infinity over here, went all the way to negative 5 and put a bracket because of this closed circle. Now what do I put? Union or unite. That symbol is in the keypad. Okay. To infinity, right? All right, so that little thing right there is the answer that goes up here. Shrink it down and put it where it belongs. Okay, that's the answer to step 1. That's the answer to step 2. Now, I would probably make the graph on my paper before I answered step 1. Is everybody okay with that? Okay, so now we are ready for example 7. All right, example 7. Once again, I'm going to need to divide by what? Divide by 3. If I divide by 3, I'm going to have the absolute value of 2 minus y is greater than or equal to negative 1. So once again, I have an absolute value inequality, so I go to my chart. I'm on the far right-hand column. What happens when you have an absolute value bigger than a negative number? I mean, they're all bigger than a negative, right? All positive numbers come out bigger than negative numbers. So it's script R. So in this, for step 1, you can put negative infinity to positive infinity. I believe it will work if you put script R as well. And then for the graph, you're going to shade the whole thing. Does that make sense? Okay, example 8. Everybody got that one down? Okay, example 8. Once again, I need to divide by 3. So divide that thing by 3. And I have the absolute value of 3 minus y is less than or equal to negative 2. Okay, so you can look at your reference sheet there. Absolute value less than a negative number. And positive, these always come out positive over here no matter what. Positives are never less than negatives. So that one's no solution. So you will probably have an empty set symbol like that to select. And then for your graph, you simply leave it blank. Okay? And we'll leave the graph blank. Everybody okay? Last two examples were a lot faster, right? So make sure you catch, man, when you get an absolute value and a negative, you need to be thinking special case. These are quick. Don't work them out. Okay? All right, and now we're ready for example 9. All right, so example 9. It's another two-step problem. And on this one, it looks a little weird because I got variables on the left and the right, correct? So we're just going to pretend like this is a positive number over here. We don't know what x is, but we're going to assume that when you take x and you add it to 15, you get a positive number, okay? So if I have an absolute value that's less than a positive number, what type of problem do I have? An and. So I need to write this as an and statement. And this is not one where you're going to want to write that shortcut notation where you write in between two things because we have letters on both sides, okay? So we're going to take this and remember how an and works. An and is either, it's less than something and at the same time bigger than something, right? So an and typically is like this. And then there's overlap. When you're doing absolute value, that's the case anyway, okay? So we're going to write a statement for both of these arrows. So the first one, I'll say 3x plus 3, or 3x minus 3, is less than or equal to x plus 15. So that would be this arrow right here. Okay, and now I need to write one for that. I actually need to scoot this over so I have enough room. I'm going to rewrite that there a little bit. Let's go 3x minus 3 is less than or equal to x plus 15. You told me it was an and problem. And so does anybody have any idea what the other statement will look like? Yeah, you keep the 3x minus 3 the same, but you flip the arrow, because the other one's going to go the other way, and you flip the sign. Oh, I forgot the x on this side. So this one's going to look like, I should probably be specific here, x plus 15. So that little red is what means opposite. Okay, so I wrote this one just like the original, but I left the absolute values off to represent one of my arrows. My other arrow is going to be represented like this. It's everything stayed the same except for this flipped over, and this sign changed. So notice I did a parentheses around the whole thing because it's the whole thing that changes. So I'm putting a parentheses around it with a negative in front. Okay, and that right there is the step that most people miss doing this problem. Okay, once you get here, you're usually pretty good at working them out. Okay, so now I got to work both of these out. To work this one out, what do? Add a 3 and subtract an x, right? I can take an x off of both sides and add a 3. So if I take an x off, I get a 2x. If I add a 3, I get a what? 18? And so then x ends up being less than or equal to 9. Everybody good with that? Okay, now on this one over here, I have to distribute that negative, so 3x minus 3 is greater than or equal to negative x minus 15. All I've done is distribute this negative sign right here to both of these. And now I can add an x to both sides and add a 3 to both sides. So if I add an x to both sides, I'll get a 4x. If I add a 3 to both sides, I will get a what, negative 12? So x comes out greater than or equal to negative 3. So I have x is less than or equal to 9, and x is greater than or equal to negative 3. So here's negative 3. Here's 9. I'm going to put one above and one below. Less than or equal to 9. Greater than or equal to negative 3. Okay, this is an and problem, so I need to overlap those two. Where do they overlap at? Okay, between negative 3 and negative 9, including those numbers. So right there is my graphical answer. What would my answer look like in algebraic notation? That would be algebraic, yep. So how about interval? So you said x is in between negative 3 and 9. That's correct for algebraic, and that's the way you would do it in math relays. Okay? What would it look like in interval notation? Negative 3 to 9 brackets around both. Is everybody okay with that? All right. Can I make the ink disappear? Does everybody have it written down? Yes. Okay. All right, so now we're ready for number 11 and 12, which are the story problems. And to be honest, the story problems are probably easier than the regular math problems, okay? So number 11, it says to qualify for gold status at Awesome Airlines, one must fly less than 34,200 miles, but at least 18,000 miles each year. If Gerald takes a 900-mile round-trip flight when visiting his parents, how many times does Gerald need to visit his parents each year to obtain gold status? Okay, well, tell me again, what is gold? What's required to reach gold status?
34.
So do you agree it's in between two things? So we're going to use that shortcut notation for in between two things. So it needs to be in between what? Less than 34,200, but at least 18,000. So can I equal 18,000? So that means I need to put a bar underneath that one. So I have to be less than this number, but at least this number. So G, gold status, means greater than or equal to 18,000, but less than 34,200. Okay, well, how does he earn miles? Flying, how many miles are his trips? 900 round trip, but we don't know how many trips he makes, right? Yes.
Why can't it be equal to 34,200?
Because it says less than.
Oh, okay.
In the thing, it says he must fly less than. It doesn't say less than or equal to, okay?
Yeah.
But this one says at least 18,000. So when you say at least, if I say I am at least 50 years old, then that means I could be 50, right? All right, so let's replace this G, okay? The G stands for gold status, but what does he have to do? He has to take 900-mile round trips. We just don't know how many, right? To figure out his total miles are going to equal 900 times the number of trips. Do you agree? So to reach gold status, 900 times his trips will tell us his total miles. So maybe G is total miles. Okay, does everybody agree that his total miles are 900 times the number of trips he makes, and that has to fall in between those two numbers to be gold status? How do I solve for T? Divide everything by? Okay, let's divide everything by 900. 900, 900, 900. Okay, so what's 180 divided by 9? Let me shrink this down first. Okay, so we have 18 divided by 9, which is 2, with a 0 left over. Okay, so that's going to be a 20. Okay, and over here, the zeros cancel. I have 342 divided by 9, which you can do on the calculator, or without the calculator, it would be what?
It's 38.
It comes out 38? Okay, so his trips needs to be, and I need to not put a little line there, okay, in between negative 20, or in between 20 and 38, and the interval notation for that is going to be 20 to 38, include the 20 but not the 38, because we had this line in the beginning and not here. Okay, so he needs to make between 20 and 38 trips to obtain gold status. Does that make sense? Is everybody good with that? All right, number 12. In a class in which the final score or grade depends entirely on the average of 4 equally weighted 100-point tests, David scores a 76, an 80, and an 82 on the first 3. What range of scores on the 4th test will give David a B for the semester? An average between 80 and 89 inclusive. That means including. Assume that all test scores have a non-negative value. Express your answer in interval notation. Okay, well, tell me, how do you find your average if you have 4 tests? You add them together, and then you divide by what? How many tests do we have here? The 4th one I do not know, so I will call it X, right? Now we still have 4. I just don't know the 4th one. So I'm still going to write divide by 4. That's how I would calculate my average, right? The 76 plus the 80 plus the 82 plus whatever X is and divide it by 4. Okay, well, if I want that to come out to be a B, then I want it to be between what two numbers? I want it to be bigger than 80, right? Include the 80 because it says inclusive. And I want it to be less than what? They say to use 89. If we were not using this little marker here, we could just put 90, right, and say less than 90. But the way they're having us do it is say do it between 80 and 89, including those numbers, okay? Which they're assuming that, you know, at the end when you round, it becomes one of these numbers, in between these numbers. Okay, anybody have any idea how I could solve for X in that case? You can multiply by 4 and get rid of the fraction. You could also add these 3 together to simplify this a little bit. So somebody add those in the calculator for me. 76, 80, 82. That's 162 plus 76. And I got to take this times 4, so that's 320. What do you get when you add them together? 76 plus 238 plus x. I also multiplied by 4. 89 times 4 would be, what's 90 times 4? So 4 less than that. Okay, so 4 less than 360 would be what? 356. So just to make sure you know what I did there, I took this number times 4 to get this. Why did I multiply by 4? To get rid of this fraction. So I took this times 4, this times 4, and this times 4. And then I added these 3 together to get the 238. Okay, what do I have left to do to get x by itself? Subtract 238. Okay, so if I subtract 238, what will I get? And what do we get over here? Oh, 82 goes on the other side, doesn't it? No. 82 and what?
320 minus
250, 238.
is 82. And then the other one's 118.
Okay. All right, so x is going to fall in between 82 and 118. So in interval notation, this is going to look like this. 82 to 118. Now, I do remember sometimes in the past, and I don't know if they have changed this or not, but they're saying they're all 100-point tests, right? So if it's a 100-point test, are you allowed to score over 100? Not, I mean, we're assuming there's no bonus points here, so you're going to have to change that. I remember that a few years ago that people got counted wrong on that. This was the right answer, but it was impossible to get that, so you had to go here, okay? So if you end up, if they count you wrong, pay attention to that. Chase? Question? Nope. Okay, anybody have any questions on those? And is that the last example? All right, so we're done with that lesson. So now you're ready to certify or practice on 2.2.